This 2008 for 3, the first problem says, oh, this is kind of a weird one because we have horizontal lines, we have line segments all the way to 3, and then we have a parabola that they give us the equation of the parabola. Now, something you must show is, it says this is the graph of g, the derivative of function f. So you must say that g equals f prime. You've got to tell everybody you know that. So this problem says we want to find the value of f of -1. Well, since they give us the value of 1 is 3, we're supposed to be thinking that we're going to go 1 to some x value for an integral because they gave us that 3 value, which in this case, they're saying we want to go from 1 to -5, which will equal a negative of -5 to 1. So again, since we are starting right here at this 1 and we are going backwards, we have to do the opposite signs of everything, just like we have on several problems already. So this first triangle, that area is 1 right there. This area has a 1 because 1 times 2 divided by 2. It's a triangle. There is 0 area on the horizontal on the x-axis, so that's nothing. And then we could do a trapezoid for the rest of this, which I guess I will do. So we're going to get this area on this side, which is a trapezoid. So we got a base of 5 and a base of 1, 2, 3. So 3 plus 5 is 8. And the height is 1, 2, 3. So base 1 times base 2 times the height, all divided by 2. So 8 times 3 is 24 divided by 2. So this area is 12. And since it's underneath, it's negative. So I've got to take the number that I had given to me, which is this 3 right here. So this is going to equal 3, and then I have to do the opposite, -1 plus 12, which is 15 minus 1, which gives me 14. So f of -5 should equal 14. Going on to the next problem, part B. Okay, this is problem 3 from 2018. Now, something that we got to notice here is it says this graph is g, and it tells you the graph is g, but then it also says the derivative of function f. So we must tell everybody that we know that this is also the derivative of function f. And then we have pieces, which mean line segments, could be semicircles on some it is, and it's all the way over here to 3. And then we have a parabola, but they give us the equation for the parabola right here. So the first question says, what's f of 1, or if f of 1 equals 3, what is the value? So what that means is, since they're giving us 1, we're going to be thinking about going from 1 to whatever, because they give us what the y value is for 1. So we want f of -5, which means we are going from 1 to -5, which is the negative of -5 to 1. Now we've already done some of these, so we're going backwards. So anything we go from here to the left, we've got to do the opposite sign. So we got a triangle right here. So the area of this triangle is 1 times 2 times the half. So that is 1. And then we got a trapezoid over here. You could make it up into a triangle and a rectangle. I guess it'd be a square, but it doesn't matter. So I've got 1, 2, 3, 4. This base is 4. This base is 3, and the height is 3. So trapezoid is 4 plus 3, base 1 times base 2 times the height divided by 2. So let's see, that's 7 times 3. That is 21 halves, which you could write as 10.5 if you wish. So, and it's underneath, so this is negative 10.5. So what we're going to do is we started at 3. So this is going to equal 3. And then we got to do the opposite going backwards. So it's -1 plus 10.5. So when I take 3 minus 1, that's 2 plus 10 gives me 12.5. So 12.5 should be the answer for f of -5. So number 1 is done. Going on to part B, I said 1A. Evaluate 1 to 6. So now we're starting at 1 that they already gave us was 3 here. And now I'm going to the right. Now this one's kind of tricky because I've got to do this just like we always have. This part, this area is just a square. 2 by 2 makes that area 4. So in other words, we are taking this and we're breaking this up from 1 to 3, the integral from 1 to 3 of g of x. And then we got to break that up into the other part. We got to add on the parabola part, which is going to be the integral from 3 to 6 of this function. And I'm going to go ahead and take this thing right here and FOIL it. So I have x squared minus 8x plus 16 dx. Okay, so when I'm going to go ahead and simplify this part right here, and I'm going to go up here and do that. So we got 2, and then inside there I've got x to the third over 3 minus 8x squared over 2, and then plus 16x. And we are going from 3 to 6. So that's going to give me 2 times 6 cubed all over 3. Now that's going to be a minus 4, and then times 6 squared, and then plus 16 times 6. And then we got to go minus, plugging in 3's in there. So it's going to be minus 3 cubed over 3 minus 4 times 3 squared it's supposed to be a 3 squared, and then plus 16 times 3. Okay, and then we got a double bracket out here because we have this 2 that has to go to everything. That right there is actually the answer to that part. Now, so when we do the actual total value of this, we started at 3, so it's going to be, oops, I lied. We don't have to start at 3 because it just says 1 to 6, so we don't care that that's already 3. We just got to get that area. So it's going to be 4 plus all of the rest of this stuff. Now, if you go ahead and solve the rest of that stuff, you're going to end up getting 10. So that other stuff over here all becomes 6, and that's 10. And if you want me to show you how to do that, I will do that at our Zoom session. Okay, then we got part C. Part C says from -5 to 6. So we're going all the way across. On what open intervals, if any, is f both increasing and concave up? So f increasing is wherever f prime is greater than 0. Now remember, this is f prime. And concave up is wherever f prime is increasing, which means the second derivative would be greater than 0. F prime is increasing the same as f double prime being greater than 0. So I'm going to highlight this one. So f increasing. So f is increasing or greater than 0 here all the way there. So there's where f is greater than 0. So that's the increasing part. And then the part where, on that part that's shaded, the part where f prime is increasing is going to be here and here. So the answer for part C is going to be f is increasing and concave up on the interval 0 to 1 and 4 to 6. And it says give a reason, so the reason is because f prime is greater than 0 and f prime is increasing on those intervals. So that would be the answer for part C. And then the last problem. Find the x-coordinate of each point of inflection of the graph. Give your reason. Well, points of inflection is usually where the second derivative changes sign. So we want to see where f prime changes from increase to decrease or decrease to increase, which is the same as saying f double prime changes sign. So if you look here, it's doing neither here, so that's nothing. It's increasing here, but it doesn't change direction. It goes to nothing again right there. So all of that is nothing. Then it increases here. F prime is increasing and then goes to 0 again. So that's not a change of sign. So here, F prime is decreasing to there, and then F prime increases the rest of the way. So the only place that F prime changes sign is at 4. So you would say there is a poi at, and it only says down here x coordinate, x equals 4 because it gives a reason, F prime changes from decreasing to increasing at x equals 4. And that's the end of that problem.